number line for irrational numbers. First we'll represent the irrational number in a number line, and we'll represent root 2 and 2 root 2, both are irrational numbers. These two numbers will represent in a number line. Now first we have to draw a normal number line. Say this is the number line for the whole numbers. To do this, we have to use the Pythagoras theorem, and the Pythagoras theorem is for a right angled triangle. Suppose this is the base of a right angled triangle and this is the perpendicular of a right angled triangle, and if we join these 2 points, this is the hypotenuse of the right angled triangle. According to the Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square, or you can say h is equal to root over p square plus b square. So we will use this Pythagoras theorem to construct the number line for root over 2. So in this number line, you can see from 0 to 1, this is 1 unit. Suppose this is point A, so AB is equal to 1 unit long. Now at point B, we can draw a perpendicular line, and the length of the perpendicular line is also 1 unit. Suppose this line is CB. Now if we join AC, then AC is the hypotenuse. So AC is equal to, according to Pythagoras theorem, base square or perpendicular square plus base square is equal to root over 2. So AC is equal to root 2. So we get the length of root 2, which is equal to AC. Now if we take A as the center and draw an arc with radius of AC, then we get the required point in the number line. Let us draw the arc. So this is the arc. So this is equal to AC itself. So this point D, so AD, or distance from 0 to point D, this is equal to root 2. See, this is the point. Thus we represent root 2 in the number line. Now how we can represent 2 root 2 in the number line? You see, this length is root 2. So we can take same length from point D. Now if we take D as the center and draw another arc with OD as the radius, then we will get the point E. This is point E. So this distance DE is also root 2. So this distance from point D to E is also root 2. So the total distance from point A, or from 0, this distance is root 2 plus root 2, that means 2 root 2. Thus we represent 2 root 2 in the number line. Now let us represent root 3 in the number line. See, already we have shown how root 2 can be represented in a number line. So this is root 2, this is point A, this is point B, this is point C, and this is the point D. So this is equal to root 2 that we have done in the previous case itself. Now AC is one line. Now if we draw a perpendicular line at point C, this is the perpendicular line CD, and this length of the perpendicular is 1, then this angle is 90 degree. So if we join AD, this is a right angled triangle. So what is AD? AD is equal to root over AC square plus CD square, and that is equal to root over AC square. AC is equal to root 2 square plus CD equal to 1 square. So this is equal to 2 plus 1 and this is equal to root 3. So this distance AD is equal to root 3. Now we get the distance for root 3 which is equal to AD. Now you take A as the center and AD as the radius and draw an arc to cut this number line. So this is the arc. Suppose this is point E. So this AE, this distance is equal to root 3 and this distance equal to root 2. So this is equal to root 3. In the number line we can write this is root 3. So in the same number line we get point D equal to root 2. That means 0 to D is root 2 and 0 to E is root over 3. Now let us represent root 5 and root 6 and even root 7 in a number line. Now in this number line you can see from 0 to 2 this total unit is 2 units. Suppose this is point A and this is point B. So AB equal to 2. Now if we draw a perpendicular at point B, that means this angle is 90 degree. Suppose this point is C, then we join AC. So this triangle ABC is a right angle triangle and this is equal to 1 unit long. So what is AC? According to the Pythagoras theorem, AC is equal to root over AB square plus BC square, and that is equal to root over AB equal to 2 square, that is equal to 4 plus 1, and this is equal to root over 5. So length AC equal to root over 5. Now you take A as the center, draw an arc AC to cut the number line. So this is point D. So this distance, so this is the point root 5 in the number line. Now for root over 6, you draw a perpendicular line at point C perpendicular to AC, and this length is 1 unit. Suppose this point is E. Now join AE. Now you see ACE is a right angle triangle. So AE is equal to root over AC square plus CE square, and that is equal to root over AC is root 5 square plus CE equal to 1 square. So this is equal to root over 5 plus 1, and that is equal to root over 6. So AE is equal to root 6. Now you take A as a center, draw an arc with radius AE. From this you can draw an arc like this. This is the arc. So this is equal to point F, and this is equal to this point is root 6. Now we can draw root 7 also. So take the line AE and at point E draw a perpendicular line. This is the perpendicular line. That means this angle is 90 degree. So this is say EF, this is equal to EF. So this is point C. Join AG. This is AG. Now what is AG? AG is equal to root over, this is a right angle triangle, root over base square. Base is AE square. AE square plus perpendicular square. This is a unit length, and this is EG square. So this is equal to AE AE is equal to root 6. So root 6 square plus EG equal to 1 square equal to root over 6 plus 1 is equal to root over 7. So this length is root over 7. So we can draw the arc. Take A as the center, draw an arc with radius of AZ. If we take radius of AZ, then this type of radius you have to draw somewhere here. You will get root 7. So you see here we have root 5, root 6, root 7. This way we can represent any irrational number like root 5, root 6, root 7, then root 10, etc. in the number line. We can also represent 2 plus 2 in the number line. So for that we already have 0 to 2. This length is already 2. So from 2 we have to take root 2. So the same process, this is 1, this is also 1, and if we take this is perpendicular, this is base, this is 90 degree, so this is equal to root 2. So you draw an arc, this is equal to this distance equal to root 2. So this is 2 plus root 2. So this point, say this is point A, this point is 2 plus root 2. Okay, we can also represent 2 minus root 2. So for that the same thing, this is distance 2. Again you take 1 unit, this is 1 unit, so this will be root 2. You draw an arc, this time draw an semicircle. So this is point A and this is point say B. Now you see this distance 2 to A is root 2. Similarly 2 to B, this point is also root 2. Now what is this point B? This is 2 minus this part root 2. So this is equal to 2 minus root 2. So this is the point 2 minus root 2 in this number line.